Assalamualaikum warahmatullahi wabarakatuh and very good day to our respected lecturers. I am Razali bin Samin. Today, our group will present about our project which is G-Clamp. For the group members, me, Muhammad Mirza bin Rostam, Muhammad Afiq bin Amizan, Dini Haikoyum Aiman bin Asmadi and Salim Ahmed Salim Abdullah.
Hi, I'm Salim and I'm going to introduce you to our project. So our project focuses on designing and fabricating a hybrid product that combines two different manufacturing approaches. The final product is a functional component that includes an aluminum clamshaft and a PLA 3D printed handle and a handle base. So this combination allows us to take advantages of the strength and precision of metalworking while also using flexibility and customization offered by additive manufacturing. To create this product, we first use SolidWorks to model the parts and we ensure that it fit properly. Then the aluminum shaft was fabricated using conventional methods like bent saw cutting, lathe turning and milling, while also the handle was produced using FDM 3D printing and sliced with Cora software. We selected 6061 aluminum for the shaft because it is lightweight, corrosion resistant, and easy to machine. The handle was printed using PLA, which is an eco-friendly, strong material suitable for ergonomic parts. The clamp assembly can be used in a variety of small mechanical applications, such as lab tools, light clamping systems, or for educational setups. The goal was to create something that's both durable and user-friendly while demonstrating the advantages of combining different fabrication techniques in one product.
So for product specification, material that we are using is aluminum alloy, which has lightweight, corrosion resistant and easy to machine. So the first part is clamp body part. The dimension is 96.48 mm height times 47.6 width times 15.2 mm for thickness. And the feature is 8 mm central through hole. So for the screw thread, the size is M8. And for the screw shaft part, the dimension is 86.16 mm height and 81.07 mm area. So for the feature is 8 mm central through hole. And the last part is swivel part. The dimension is 7.60 mm height times 7.60 mm for the outer diameter. So for the feature is inner diameter, which is 6.35 mm inner diameter central hole for fastening. So for the first part of design analysis, which is on clamp body, G clamp. So the type is static analysis. For the type of material that we use is aluminum alloy 1060, and the yield strength is 275.7 megapascal, and for the applied load is 50 newton, and the fixture on the drawing is on the inner arc. And so for the first diagram is stress diagram. For the maximum stress von Mises is 2.017 megapascal, which is below than yield strength. So it's safe under load condition, which is we set on 50 Newton. For the displacement, the maximum displacement is 0.001022 millimeter. So the small amount of displacement, so it does not affect the structure as it remains stiff. And the last one is strain. The maximum strain is 2.468 times 10 to the power of -4. So it's within elastic range of aluminium. So no permanent deformation. And next for design analysis, we analyze on swivel. So same goes to the first analysis. It will be static analysis. The type of material that we are used is ABS plastics because the SolidWorks does not have PLA, which the actual material that we are used in the fabrication is PLA. So we replace with ABS plastics. For the yield strength is no yield strength because it is plastics, and same goes to the first one. The applied load is 50 Newton and the fixture is on the top surface of the uh, swivel. So for the stress, maximum stress von Mises is going to 0.7317 megapascal. So it's safe under load condition. So 50 Newton does not affect uh, the significant stress. And the next one is displacement. So for the maximum displacement is 0.7719 times 10 to the power of negative 3 millimeter. So it's small amount of displacement. 50 Newton of load does not affect the structure. And the last one is strain. Maximum strain is 3.343 times 0 to the power of negative 4. So no permanent deformation and no plastic deformation occur.
Okay, this is a process flow of clamp fabrication. We have 6 process flow that for the first one, we design all components using SolidWorks that have 4 components. Then for the second one, finite element analysis, we do an analysis for each part for the component to simulate load conditions to validate structural strength and safety. If strength not enough, we modify design based on stress, displacement or strain. For the third one, cam preparation, we import final CAD files into SolidCam, then generate tool parts for milling, post-process to create G-code for CNC machines. For number 4, CNC machining, we use CNC milling to verify tolerance and surface finish during machining to make it easy. For number 5, for finishing operation, we manual deburring, taping, and dimensional checks. For lastly, assembly, we assemble all the parts to make it clamp clamp and perform final fitting and functional testing.
Okay, next we have 4 details of manufacturing process. For the first one, components are designed using SolidWorks. We use SolidWorks to design the clamp and handle. And for the second one, G-code generated for CNC milling machine. And for the third one, for the material use, we use aluminum alloy. And for the last, manual threading. We thread clamp body using threading tool.
So for the discussion, this project combined metalworking and also 3D printing to fabricate a clamp consisting of an aluminum shaft and also PLA plastic handle. The aluminum shaft provided strength and durability but also required very precise machining. And the 3D print PLA handle was quick and easy to produce. Even it lacked strength under sheet of pressure. The clamp was also designed to withstand an applied force of 50 Newton and with a safety factor of 3. And we also learned that both parts must be manufactured with high accuracy to ensure a proper fit during assembly. So overall, this hybrid manufacturing method proved effective and also can be further improved by using stronger plastics and optimizing the production process. Move to the next slide, which is the advantages and also disadvantages of our project or product. First advantage is high strength. We use aluminum shaft. The aluminum shaft can support the applied load with a safety factor of 3, making the clamp reliable and also durable.
Second, fast production. Fast production, and especially the PLA handle. 3D printing, the handle is quick and also cost effective, allowing for faster prototyping and also production. And last one is the material efficiency. Combining both methods reduce material waste and also utilize each material strengths very effectively. And next one is disadvantages. First is the limited strength of PLA. Like I mentioned before, we use 3D printing. The PLA handle is weak under heat or pressure, which may be affect overall climb performance. Second one is precision required. Both parts must be accurately made to fit well during assembly, and if any mismatch occur, it can cause failure. Last one is different material behavior. Differences in thermal and also mechanical properties between plastic and metal can affect a long-term performance.
So in conclusion, this project demonstrated a successful integration of traditional and modern manufacturing techniques by combining a machined aluminum clamshaft with a 3D printed PLA handle and a clamp base. The result was a product that balanced mechanical strength with ergonomic designs. The precision machining of the aluminum parts ensured durability and solid structural foundation, while the PLA handle added lightweight and customizable features. The assembly process confirmed a proper fit and reliable performance, and final testing validated the design. Most importantly, when subjected to stress simulation using ANSYS, the product showed excellent performance, and the analysis revealed that a very low deformation will happen, and the stress levels will within the material limits, confirming the product's ability to handle mechanical loads effectively. These results further supported the viability of using both CNC machining and 3D printing to produce functional hybrid components with confidence. Thank you. That was all for our project.
So that's all for our group presentation. Thank you.